Okay, hello everyone. This is Clarke Towson here, CEO of INTJ Billing. So in this video, I'm going to show you one single equation. Now, this is the most important equation in flood modelling and how it proves that the special building overlay at or over 7 Cullen Court cannot be physically valid. Okay, so this is the equation that Melbourne Water, Engeny, and every hydrologist in the country uses. It's also the equation that the people that I used to work with, the PhDs in computational fluid dynamics, used to use at DSD Group. All right, so this exposes something devastating. The model that Melbourne Water and Engeny used predicts water flowing uphill. So let's go through this now, okay? So here's our formula, Navier-Stokes equation, depth averaged momentum formula. What this says is partial U, partial T, plus U dot del U equals minus G del H minus G sub F. All right, so where U is equal to the depth average velocity vector, T is time, okay, here's our time, G is the gravitational acceleration, H is water surface elevation, or equivalently depth plus bed level, S minus F is friction slope, so this is Manning's Darcy-Weibach friction losses. And here's our spatial gradient operator here, okay? So what that's saying, so we've got negative G del H, okay? So that's the gravitational term that forces water to move downhill. So that's right here. So that term's gravity itself. And what it dictates is that water can only move from high to low, okay? So any model that requires water to move the opposite way, right, violates the laws of physics. As we can see with the Engeny model, which of course is based on Melbourne Water's model. And remember, let's not blame Engeny. Okay, I don't want to blame anyone. Okay, so our gradient, if the gradient points uphill, as I said, the model is wrong. Okay, if the model predicts water flowing against the gradient, it's physically impossible. Now, as I said, every hydrologist knows this. Now, of course, Melbourne Water and Engeny's models lack field verification, and that's where my work comes in. I submit that field verification is exceptionally important for flood models, right? So here's our formula, all right, depth averaged momentum, okay? And it's the single equation that proves the SBO at 7 Cullen Court cannot be physically valid. So remember, here's our Engeny flood map, 1% AEP, proposed conditions, flood depth. Here's our water in the Cullen Court bowl. Remember the Cullen Court optical illusion. Here's our water over the driveway. Here's our water over the TRZ2 zone block, okay? Remember the driveway crest at 7 Cullen Court, okay, is a higher head boundary. So it's physically higher, 30 mil higher. Remember, here's our measurement, 30 mil higher than the road bowl here. Okay, here's our road bowl. So the crest forms a hydraulic barrier and water cannot climb over it. So the crest controls flow direction. So it forces everything downhill into the road bowl, okay? Remember, into the road bowl. So here's an image here of 7 Cullen Court. Here's our road bowl, the cul-de-sac. Here's our TRZ2 zone block. I've placed these arrows. It shows how the TRZ2 block is higher than the road. You can see the road slopes down into this gutter here, okay? So when the rain falls down in a storm, we get our ponding over here, and a slight section just on the driveway. Remember, driveway is not on tidal. That section's not on tidal. at 7 Cullen Court. So this is, and remember here's our road verge, our council nature strip, okay, which extends up to around here, and you can see that's uphill as well, okay. All right. The private title starts approximately where this post is across, okay. So really important. As I said, the crest forms a hydraulic barrier. Water can't climb over the gutter here, okay. So any model that shows overland flow crossing the crest, so this crest here as well as the driveway crest, is invalid, right? It's simply invalid. So, I mean, the model's violating the governing equation of fluid mechanics. It's predicting uphill flow, right? So this is not my interpretation. It's not a difference of opinion. It's a fundamental breach of physics, right? Fundamental breach of physics. So here's our driveway crest here, flow direction. Remember, we've got our slope here. Okay, the driveway slope, and remember this is council verge, and this section of the driveway is also council, not on title. We get our water flowing downhill from our 1% gradient into the gutter here, and then flowing down here to our council municipal pit here. Okay. So a couple more photos. Here's some ponding over the front section of the driveway. Remember, not on title. Not on title. Title of 7 Cullen Court starts around about in this section here. As you can see, there's no water egress there. Here's our flow direction, 1% slope. Okay. Another photo, the Cullen Court bowl. Remember the Cullen Court hydraulic optical illusion. Here's our driveway with a slope, 1 degree slope down into the gutter. Water flows down here and then down in this direction to the council pit over here. Remember the bowl at this section towards the top here flows towards the TRZ2 zone block, okay, and we get our nuisance ponding, okay. So here's our nuisance ponding outside the TRZ2 zone block. Again, here is the slope of the land, okay, and our nuisance ponding is here. All right. So this, the special building overlay over my mother's property can only be valid if overland flow can physically reach it. Remember, here's our just where the bollards here are here, private title, okay, council verge in this section here, all along, council verge, and then private title, okay. Remember that the road bowl is lower, the crest, okay, the curb is higher, friction slope works against uphill motion, gravity prevents reverse flow, okay, the hydraulic gradient points the wrong direction. So for the SBO to be valid, water would need to climb uphill, remember, climb uphill, so the Cullen Court bowl, pours with rain, we get our nuisance ponding here, the Cullen Court bowl, the water would have to climb uphill, over the curb, okay, right, up over the council nature strip here, and then onto the TRZ2 zone block. And of course, this is against the Navier Stokes equation, right? And no hydrologist alive would defend that. It just can't happen in the real world, okay? All right. So remember our equation, the depth average momentum equation. Okay, the same equation Melbourne Water uses. Proves that the SBO at 7 Cullen Court is not physically possible. The driveway crest blocks all overland flow. The gradient points downhill into the road, and no model can override gravity. I mean, physics don't lie. Okay. Now, all of this I've submitted to Melbourne Water and Hobson's Bay Council. What you've seen today here is it's not my opinion. It's first principles, and first principles always win. All right. Mm-hmm. I mean, it's just obvious. Like when you see the photos, okay, and you look at the Navier Stokes equation, it's all very obvious. Okay, very obvious. All right, quick sidebar. Let's talk a little bit about the Navier-Stokes existence and smoothness problem. Some of you might know about this problem. There's actually $1 million prize. Okay, so if any of you are bored, okay, there's $1 million prize waiting for anyone who can solve one of the biggest problems in mathematics, which is known as the Navier-Stokes existence and smoothness problem. Okay. So in simple terms, the problem is, given an initial velocity field in 3D, do the Navier-Stokes equations always produce a smooth, globally defined solution, or can the equations blow up? So prove it or disprove it, and you're a millionaire. Okay, and remember, okay, there's only one at the Clay Mathematics Millennium Prizes that has been solved. That's the Poincaré conjecture. Our friend here, Grigory Perelman, solved the Poincaré and famously refused the $1 million prize. Okay, he refused it. I take my hat off to the man. It's actually hilarious, right? I mean, there's a video on YouTube where he didn't turn up to accept the prize. It's interesting stuff, right? But I mean, look, the guy's a genius. All right, he solved the Poincaré. So yeah, if any of you are bored, okay, remember, $1 million prize, Navier-Stokes existence and smoothness problem. This has got consequences. It's very, very important. Okay, very, very important, particularly for turbulence. Okay, now of course I came across these problems working in defence. Okay, and it was a bit of a running joke. I'd say to some of the CFD people, "You're busy fellas. There's a $1 million prize waiting, $1 million prize waiting for you if you can solve the Navier-Stokes problem." But I mean, look, obviously, my background very important to solve this this problem for the SBO at 7 Cullen Court. But you can't argue with the depth average momentum formula, the Navier-Stokes equation, right? You just can't do it. It should be completely obvious by now that the model's broken, the Melbourne Water model's broken, therefore the Engeny model's broken as well because it's based on it. And there we are, right? All right, that's it from me, everyone. And sorry about this this photo here with the with the skip. I ordered the skip to take care of the Department of Transport's road reserve. Not very happy with them. They let their reserve overgrow, and I had to clear it all out. Okay, so I'll get you a better picture of the driveway next time. All right, that's it from me, everyone. I'm Clarke Towson, CEO of INTJ Billing.